Hi, I welcome you back. And the topic of today's discussion is going to be Kekule's structure of benzene. In the previous lesson, we were all confused that whether benzene contains unsaturation or it does not. There were some experiments which were support that yes, benzene contains unsaturation. But there were some other experiments which were saying that it is not reacting the way any unsaturated molecule should react. So there were two different types of experiment that were pointing in two different directions. So previously there was confusion. But in today's session and from now onwards till 2 and 3 next session, this confusion is going to get resolved. So today's lesson is going to be the first step towards the derivation of the structure of benzene. So Kekule was the first person. His name was Friedrich August Kekule. Probably he was a German scientist. And way back in 1865, he claimed to be the first person to say that I have derived the structure of benzene. He said that okay, C6 is the molecular formula of benzene, but let us move further. And he said the carbons of benzene are arranged in hexagonal ring. Like even today we write benzene like this. He said the same thing, that you arrange the 6 carbons in a hexagon and you place 3 double bonds inside it, and the position of double bond is like this, that there is one double bond, then there is single bond, then again a double bond, and then again a single bond. So likewise the benzene contains 3 double bond and 3 single bond. And he said that there are two canonical forms of benzene. The first one is where the position of double bond is like this, and the second canonical form of a benzene is where the position of the double bond is altered. So Kekule said that there are two canonical forms of benzene where the molecules contains 3 double bonds and 3 single bonds. Actually, there is a story behind this as well. The structure of benzene came into the mind of Kekule while he was dreaming. He was sleeping and he was dreaming. So he saw a snake eating its own tail. So that is how the idea of arranging the carbons in a circle came into the mind of Kekule. Because previously people were trying to arrange the carbons in different shapes and patterns. There were linear arrangements, there were branched arrangements, but people were not able to satisfy the molecular formula and the other evidences that could be justified by their representation. So the cyclic arrangement of benzene was given by Kekule. The Kekules model was accepted on the few bases. The first one was that it justified that there are 6 carbons and 6 hydrogens in the structure of benzene. So if you count the hydrogens and the carbons in benzene, let me take you back to the Kekules structure. Here if you count the number of carbons, it will come out to be 6, and similarly if you count the number of hydrogens, it will also come out as 6. So Kekule was the first person who was able to give a representation that was involving C6 and S6 configuration. One another fact on the basis of which Kekule's model was accepted was that in Kekule's model, all the carbons and the hydrogens are equivalent. And it was supported by the fact that when benzene is reacted with bromine under the presence of a catalyst, it gives only one form of benzene. So let me take you back to the Kekules structure. Here, if you replace any of the hydrogen of this molecule, it will give you the same bromobenzene compound because all the hydrogens are equivalent. Similarly, all the carbons are equivalent. So it must give any compound as the same compound. You replace this hydrogen, it means the same thing. You replace this hydrogen, it also means the same thing. You replace any of it, only one type of compound will be formed. So equivalence of carbons and the hydrogens was another reason of acceptability of Kekule's model. But there were some flaws which were there in Kekule's model of benzene. Let us start to discuss them point by point. We are going to discuss 3 points actually in which the Kekule's model will fail. So the first point is the model did not comment on the stability of benzene in the presence of oxidizing agents. As we have previously discussed, that any alkene gives such kind of reactions. But benzene, on the other hand, does not give such kind of reactions in the presence of oxidizing reagents. So this was not explained, or no comments were made on the stability of benzene by Kekule's model. So this was the first drawback of Kekule's model. In the second point, we are going to see that as per Kekule, there are 2 canonical forms. So the first form can be where there is double bond over here, and the second form can be where there is single bond in place of double bond. So if you take one particular compound, 1,2 dibromobenzene, then there must exist 2 canonical forms of the same compound. The 1,2-dibromobenzene must exist as this form, as the first form, and in second form it should exist as this. But that is not the case. In experiments, if you see, there is only one form of 1,2-dibromobenzene, and that is this form. This was not given by Kekule, it was given by the resonance model, so that is why it is written here. Otherwise, the Kekule's model was saying that these are the 2 forms in which this compound should exist. But in real, it exists only in this particular form. So this was again a drawback of Kekule's model. Let us take the point number 3, which says that the Kekule said that there are 2 types of bond in benzene. One is single bond and the other is double bond. But if you see the X-ray diffraction structure of benzene, it shows that there are no double bond and no single bond. Instead, there are partial single and double bonds. It means there is no bond like this particular bond is double bond, this bond is double bond, this bond is also double bond. There is nothing like this. All the bonds are equal in length, and the length of these bonds is in between of single and double bond. So this statement was also wrong, that there are alternative single and double bonds in benzene. So these 3 were the drawbacks in Kekule's model. Finally, in conclusion, there were 2 points on which Kekule's model failed. One was to explain the benzene's exceptional stability against oxidizing agents, and the other was equality of the carbon-carbon bond lengths that was failed to be explained by Kekule's model. So due to these limitations, the Kekule's model was not finally accepted. It is not accepted till date. There are 2 better models which better explains the benzene structure, and the name of those models are orbital overlap model and the resonance model of benzene. We will look at these 2 models in detail in the coming lessons. So for this session, that was enough. I have explained to you that what was Kekule's model, what were the points of its acceptability, and what were the limitations in Kekule's model. So for learning the new models, stay tuned. See you in the next lesson.